Welcome to the SafeSight Safety Share on the MRC Rail Runner. This video is focused on sharing some of the MRC Rail Runner's ability to mitigate some key risks and challenges that are involved in MRC development and improve the overall management and oversight of the MRC development as well. So regarding SafeSight, we are an innovation company, totally Canadian based. We're located in Northern Ontario, and our focus is really the development of innovative solutions, their manufacturing and supporting them with an intent to transform safety in mining on a global level. And everything that we do is focused on dramatically reducing the level of risk to workers or completely removing them from harm's way. Before we get into the details of the safety share and the risks that are mitigated, I thought I'd give you a little bit of an overview of the Rail Runner itself. The Rail Runner is a mechanical unit that autonomously clips onto the rail and performs a round trip from the nest to the face and back. And during that trip, it will capture high definition video and images of the rays and the face. It is equipped with a gas sensor payload that allows the Rail Runner to report peak levels throughout the rays and the face. And using LiDAR technology, it will create a 3D point cloud of the development in its current state. Now, in terms of the risks that we focused on mitigating as part of this safety share, you can see them on the slide there. Really, it's the key challenges around falling rock, gas levels within the rays post-blast, as well as anyone who has to go underneath the rays in its unsupported state or during its development. Other challenges that we believe the Rail Runner addresses that we'll talk about in this video are rail orientation, as well as the supervision and traceability of the development as a whole as it progresses shift over shift. With respect to the first risk that we wanted to talk about, really is falling rock, and this is the risk of any loose post-blast that might be hung up and that the crew, as they start their work, would be unaware of. And I think that's really the main benefit of the Rail Runner is that in the current development environment, workers often have to go into an unknown void. With the Rail Runner, those unknowns become knowns. So let's talk about how the Rail Runner addresses or mitigates the risk of falling rock for workers and supervisors. In terms of the context of that, you have to really look at the standard operating procedures. So let me describe how the Rail Runner actually is deployed. Essentially, it clips onto the rail with a clamping system. It takes about 2 minutes to deploy. And then using a tablet, the operator can turn on the high-def video and the LiDAR scanning and essentially instruct it to head to the face. And then it's basically just wait for the unit to return. On return, the unit will essentially have on board video and point cloud information that can be reviewed at the nest in the moment. So you can see in the associated video here some footage of the Rail Runner clipped onto the rail and running this race. Now this is a survey we were doing, so you'll notice the raise is well supported, but in the example that I'm showing you here, we were capturing a full survey of the raise. It's a 250-foot raise, so as you can imagine, a surveyor from underneath the raise is not going to get the complete point cloud image of the raise. So the example shows you the kind of video that the shift supervisor or the worker could then view prior to entering the raise. So they can see the face, they can see the raise itself, and determine if there's any risks. The gas sensor will be picking up any atmospheric issues, And this allows the crew to understand what they're about to work in, and if there's any pre-shift work that they would have to do to make the environment safe, whether that's getting rid of any loose or venting the rays to make sure there's no dangerous gases. As I mentioned, the Rail Runner does have a payload gas sensor. We use a Draeger XAM 5000, and that unit is strapped onto the Rail Runner and captures levels of oxygen, carbon monoxide, hydrogen sulfide, nitrogen dioxide, and sulfur dioxide as peak readings. And as you saw in the previous video, once the Rail Runner returns, the operator basically has to just remove the sensor and check the peak levels and all those gas categories. And again, they can determine is the air quality safe. They can look at the video to determine if there is any loose or any risk on the rail or at the face or in the rays itself. So once again, just removing the unknown and making it known conditions so that no one ever has to run into the rays, not understanding the quality of air or any risk of falling loose. Finally, as part of the development, regular surveys are required as the development gets higher or longer. Those surveys become more difficult, not only from a shadowing perspective, but you have surveyors underneath unsupported ground. So the Rail Runner removes the need for surveyors to be involved directly as it is surveying with each run. So again, if you remember the standard operating procedure, clip on the rail, activate the LiDAR, send the Rail Runner up the rays to the face and back. And what's returned, there are two things. There is a preview window so you can see a low rendering of the rays in a 3D image. But then on board the unit, there is a full point cloud that can be loaded into whatever site software is being used to manage development, whether that's Deswick or some other solution. And engineers can review the details of the point cloud and the condition of the rays. So here's an example of the rail runner. You can see this is the LiDAR unit on the rail. It's going to traverse the rays, and as it's doing that, it's capturing the video as you see here. That video will then be uploaded as a point cloud that can be viewed by anyone with authority to look at it. And the rays and the development can be assessed, and each shift plan can be modified based on that detail. So let me just talk a little bit about some of the other mitigation, or I guess improvements, that the Rail Runner can apply to the MRC development. Key areas that we wanted to focus on in developing this utility was ensuring that the ray stays on target, making sure that there was optimum supervision of the rail installation, as well as things like raised dimension and development overall, and then really creating a traceability for that supervision and oversight. So the post shift standard operating procedures to facilitate this really involves, at the end of the shift, the crew uploading the Rail Runner point cloud video and HD images to our mine site portal, which I'll talk about momentarily. So the data is moved from the unit to a USB, and then as soon as there's Wi-Fi connection, that USB can be uploaded to the Rail Runner portal, and anyone who's authorized can view all of this data over the cloud and provide insight, approvals, or feedback to the next shift plan or the development overall. So again, benefits on being able to export that data. You now have a 3D point cloud to review. You can see the example here is of a 900-foot raise that we surveyed. The white line in the image is the planned azimuth or orientation of the raise, and the as you can see, the point cloud's the actual development that occurred. So this point cloud can be reviewed on our portal, and from that perspective, had this been done shift over shift, this was done at the end of the development once they'd broken through, but had this been done as part of the development, the slight deviation you see in the development and the actual planned orientation of the rays could have been corrected in the moment. As you can see, it's coming back onto the target area, but that deviation was unnecessary if it would have been managed differently. So the LiDAR creates this capability to manage the rail orientation, the raise orientation on a shift-by-shift basis. Once the data is available, it's put up on our mine site portal, and the portal essentially allows for a secure cloud-based environment. You can see here where every loaded instance of the Rail Runner run is viewable by authorized personnel. And you can see in this image that you can view the point cloud in real time and manipulate it as a 3D model. You can download the point cloud and import it into whatever necessary or current solution you're using to manage your surveys and your site development. And in addition, you can see there's a video associated here, so you can watch the video of the Rail Runner as it was capturing the data in its last shift. And then finally, the document section you see here allows the supervisor to upload a PDF that is a summary of their review and essentially their endorsement to continue the development to the next shift. So these elements all together create a shift over shift or week over week, whatever you choose to do, but a traceable environment that allows you to assess what the supervisor determined based on looking at the data, as well as looking at the actual data that that assessment was based on. So all those things together create a very tight oversight capability to make sure that not only is that the development is safe, but that it's effective and optimal in terms of hitting its target. And that is some of the key safety share elements of the MRC Rail Runner. There's lots more information available on the Rail Runner and our other safety innovations, and you can find those on our website at www.safesightxp.com. Thanks again for listening, and we hope that this is helpful and gives you inspiration to safer sites.